Buongiorno, everybody, and welcome. Thank you for coming here instead of having lunch. I apologize for whomever decided that this topic is so kind of, let's just put it at the lunchtime, no one is going to show up anyway. And instead, you proved them wrong, so thank you. My name is Vittorio Bertocci. I am a principal program manager in the identity team, and specifically in the developer experience team, where I work on developer libraries and integration with developer workflows, Visual Studio and similar. In the next 74 minutes, I'm going to tell you about how to integrate your native applications or mobile applications with Azure Active Directory, and we'll see how that can be fun, but especially very, very useful, as in like there are a number of scenarios that you cannot literally do if you don't go through Azure Active Directory. Now, this is a training event, or at least that's what I was told, so please do not expect any visionary slides or big announcements or about the future and similar. I expect your bosses to hold you accountable when you go back home to have learned new tricks and show that you are more effective and the money spent for sending you to Atlanta were well spent. So I'll do my part to try to keep you with those tricks. How many of you guys have a Visual Studio installed on your machine? Oh, very good. And how many of you actually open it every day? Very good. So as is customary, as I say at this point, there are free exits, which are easy to access. So if you are an administrator and you don't care about development, by all means, please take advantage of those exits, like the gentleman right in this very moment. Thank you. Because don't write in the content like saying, oh, I saw identity, I thought this was for administrator. It isn't. It really is for developers. Very good. In terms of what we are going to talk about, we are mostly going to focus on how to get tokens from your application. The idea is that you want to integrate with Azure Active Directory so that you can access the services that trust Azure Active Directory as the source of authentication. And as such, the entire game boils down to, I have a certain platform, I have a certain application topology or dev stack, how do I get tokens? And how do I manage sessions in the easiest possible way? Then we are going to spend some time on understanding in deeper terms how Azure Active Directory models applications. Azure Active Directory is used in a number of different scenarios, and as such, it has a pretty complex object model, which has to support all of these various use cases. And so we'll go a bit deeper than you would normally do, because you'll discover that once you connect the dots, you'll be far more effective in troubleshooting or in designing your systems. And so it's going to be a bit of an investment. It's not easy, but hopefully we'll get there together. And then we'll spend some time digging on specifically the Microsoft Graph, which is probably the most important API you can talk with today that accepts Azure AD. Of course, also Azure. How many of you went to Microsoft Graph sessions this week? All right, very good. So you are already sold. I will not try to sell you anything. I'll just show you how to connect. It wouldn't work anyway. Like, what credibility do I have here? All right. Actually, I lied. I have only one slide that I get from the marketing team, and it's the braggadocio slide in which we can show you that Azure Active Directory is a true behemoth. I don't even know if I pronounce the word correctly in English. Behemoth. Help me out. Correct? Yeah, fantastic. It's like one rare case in which I pronounce correct. And the point is that Azure AD is the backbone of pretty much all of our cloud services for business. Every single time a company uses any of our services, Office 365, Azure, CRM, Power BI, you name it, they are actually relying on one Azure Active Directory tenant somewhere. And as a result, we have these mind-boggling numbers. Like we have to scale like crazy. We have to be available all the time because that's sustaining one of our main revenue streams. So we have like many horses in this game. So the idea is that you can take advantage of the same system, which is critical for us. So you should be able to do this with full confidence. And I'm not going through the details because, again, not trying to sell you anything, but that's just for making you feel good. Do you feel good now? Yes, no. I'm already sleeping. Very good. All right. So let's take a quick look. Actually, how many of you were at my session yesterday? OK, half the audience. I have to apologize to you guys. There is a significant overlap between the two sessions, mostly because we are talking about the same service, we're just consuming it in a different way. So please be patient with me as I go through similar stuff. In fact, it will be interesting if you notice the differences. Trick for seeing if I manage to keep you awake. No. All right. So this scenario that you see here is the classic scenario you are used to. Traditional on-premises enterprise, you have one domain controller, perhaps one IDFS, one user. You have applications which run on devices that live on the local network. And everything is good and easy. Let's say that you are in your tank, and everything is mediated by the domain controller. At the network layer, you get authentication. So you, as a developer, you don't even think about it. You just go on IIS and you say, use integrated auth. And you are done. Unfortunately, or fortunately, this doesn't work as well when you start to take advantage of services that live outside of the boundaries of your enterprise. And of course, I am biased because, again, my salary comes from here. And so for me, the applications that you absolutely want to buy are Office 365, Azure, SQL Azure, and similar. And those applications, especially Office 365, will occasionally need to go back to your local system and namely authenticate your users so that we know which mailbox to show you, and do things to the effect of read user attributes like licenses or groups or subsidiaries and stuff like that. However, unfortunately, these cannot happen because the firewall, which here represents as a little dome. Do you like sci-fi? Who reads sci-fi? There you go. I read sci-fi a lot. So this one is straight from one of the books. And the idea is that if Exchange needs to know something about the user, actually, they cannot do this because there's the DOM. Also, these OK, great. And so basically, albedo, it jumps out. So how did we solve this? Again, we were very, very motivated to sell you Office 365. So we solved this using brute force. We substantially took. Say again? I said best answer ever. I absolutely agree. See, and I do a testosterone voice. Substantially, what we did was to replicate in the cloud the relevant information that you need for this kind of workloads. And specifically, you need two main things. You need the ability to authenticate, which you could have done using Federation, but that would have been like a death by 1,000 cuts. Let's say that if I'm selling my product to millions of companies, then I can't go to dinner with every administrator to set up their federation. So we needed a more streamlined way of authentication, and you'll see that we achieved that by having endpoints directly in the cloud. And the other part that we had is that we replicate information about the users, groups, and similar, so that what happens is that whenever a cloud service needs to access this information, they don't need to go back. They just work directly with the cloud, which works pretty well, actually very streamlined. Now, one thing that I need to mention is that normally when we do this sync, we do not sync credentials. Let's say that credentials remain back home, and then we just have a way through Federation to involve the local provider. However, if you decide that you want to have no footprint on premise for authentication, then you can also sync the hash of your passwords. So that's one possibility. Another thing that becomes possible here is for companies that do not really need to have an on-prem footprint, you can eliminate it altogether. Let's say that you can have only your cloud-based directory, which, by the way, is what I do with all of my demos, like why firing a VM when I can just have everything in the cloud. So this enables many scenarios in which reasonably small companies that normally would not have invested in a directory, but that can really use a directory or equivalent, and now have a very cheap way of getting on board. And now this thing was interesting because we did it for ourselves, but we then realized that the same system can play the same role that the traditional Active Directory has played on premises. It provided this central place where every application could outsource identity capabilities and identity management, so that every application was free to develop whatever business function they wanted, and relying on the fact that there was this centralized location. So here, we can do exactly the same for your online applications. Like this application. Let's add a little cloud because it's stylish, and voila. And we can do exactly the same. Let's say that your application can now be secured with the exact same infrastructure. And yesterday, I did an entire session on how to protect that application. Instead, this time, I will do an entire session on how to, when you have your native application, which I can run here, or can run here, substantially how to, from this application, access any of the assets that you have protected in here. So, pretty straightforward. Yes, no, maybe. Mostly maybe. Very good. Healthy skepticism, I like it. So what is a native application? I was going to ask you, but too late. I already stole my thunder. A native application is substantially anything at all that does not get content straight from a browser. So anything, and actually also something that runs on the user device as opposed to a server. Like if I'm running something on the server, typically like code behind of a website or a long-running process and similar, I wouldn't call it a native app, although it's not using a browser, mostly because once on the server, you can do things that you cannot do here. Like, for example, on a server, you can have a certificate, you can have keys, you can have credentials, which indicate the identity of your application. Instead, a native application is something that runs on your phone. It's something which runs on your management console on your PC. It's Word. It's Outlook.exe. Anything that runs on your device and that is running its own code instead of just stupidly reading and executing whatever the server is doing. Like I see some white hair here, so you'll remember the smart client versus dumb client of a few years ago. The idea is the browser really has no soul. It will do only the things that the server says, whereas these guys all have their own personality, their own code. So that's the main difference between those two. Now, interestingly, one of the big focuses that we have in this context are mobile applications. What makes mobile applications special among the native apps universe? The idea is that when you're running in a mobile operating system, you typically have a deployment system based, for example, on application stores. So that means that you, as a consumer, can navigate in one of these stores, and you'll find applications that probably had some level of vetting, but you cannot really wholeheartedly just trust. So the idea is that the OS will isolate this application from the resources of your device, like, for example, your location or your contacts, all the things that are actually in your device, and will mediate these through a sandbox. And so when you do authentication, this becomes very important because typically you want things like single sign-on across applications. But when the operating systems put every application in their own little sandbox, then you need to find strategies for working around this. The other point that we have here is something which has been a bane for native applications for the last 10, 15 years. Actually, how many of you write native applications? Not a lot. Everyone else is like, well, yeah, let's see what this is all about. Maybe you'll feel inspired, and before the end of the day, you will have written your great native application. So, and of you that you raised, how many do iOS? 1, 2, 3, 4, 5. Great, thank you. Android. Windows Phone. Thank you. What about the desktop? Do you write like a WinForm app, WPF apps? OK, that's what I thought. Great. So the big difference, again, between WPF and all these other platforms is this sandboxing. Like on WPF, you are kind of a user, so you can do whatever the user can do. And if you want to share a file with another process, sure, who cares? Instead, for all the other guys, you can't do that. But the main point here is distribution of those applications, and maintenance and update is a royal pain in the neck. Because like the moment in which the bits left your distribution center, then who knows when the user will update again, if they will ever update again. So when you are dealing with authentication, which is by its very nature a very dynamic process, then this is not a very good arrangement. Let's say that tomorrow your company gets audited, and all your direct username and password authentication are no longer acceptable. You must now always use a two-factor authentication. That's not like a hypothetical, maybe an asteroid will eat Earth scenario. This happens on a weekly basis to my customers. Like you have to actually go and figure out how to do 2FA everywhere. Now, if you deployed your code with in your code the dialog that comes out and asks for username and password, and now you have to inject these 2FA, good luck keeping your job. It's going to be very, very, very hard. And that's just one aspect. There are many other aspects of modern authentication which entail something which goes beyond authentication and still requires user interaction. So how many of you have a Facebook? Thanks. How many of you are lying? Like the ones that didn't move a hand, come on, I don't believe you. That's impossible, unless you come from a country where they block it. But anyway, I'm sure you have a common experience of like some of your friends with way too much time on their hands asking you to send the water for their starving sheep or something to that effect. Exactly, they must die. So once they do that, typically you'll see Facebook popping out a dialog saying, hey, this time-consuming program would like to have access to all of your contacts so that I can spread the disease to everybody else and make you look like an ass. That dialog is, in common parlance for security, is called like the consent dialog. And it's a dialog which is used for involving the user in the process of deciding whether to share information, whether to delegate an application to access resources on his or her behalf. Now, this thing is very common. It's starting to be very common also in business context. As in, like, there might be ISVs that give business-based applications accessible to end users. End users in a company which can actually, I'd say, individually opt in to use a SaaS application without involvement from the administrator. That's a very, very convenient way of pushing your app. Any of you using Slack? All right, so you guys are familiar. Like you're going to get an invitation, you join Slack, and there is no administrator involved. But once you get to a certain size, then the administrator gets involved. So in order to enable this, you need to have a way of injecting arbitrary UI. And if you wrote the UI in the code, you have a problem. So that's how, that's why for native applications, for us and for the rest of the industry, what we do is that we really reuse the work that we have already done for web applications. As in, web clients might be dumb, but they do an intelligent thing, which is this thing of outsourcing to the server the rendering of a credential gathering and the consent page. So here, that's exactly what we also do. If an application needs to, just in time, gain a token for accessing an API, what happens is that your application needs to have some code, which will typically come from libraries, and as a shareholder, I hope it's our libraries, which reach out to one endpoint here. It's the authorization endpoint in of parlance. And it renders whatever UI the service decides to show, like credential gathering, consent gathering and similar. How it does it, it depends on the platform. If I am on a console app on the desktop, this will pop out a dialog with a browser control inside. If I am on iOS or Android, there are ways of invoking the system browser on the device. So I'll just take a little dip in the web and have this interaction in the web. And then what happens is that if I successfully work this thing out, I will get back a code. A code is just like an opaque string which indicates, yes, this user successfully authenticated and this user consented. And then the next step is to go to another endpoint, which is the token endpoint, presenting this code. Now, the ones among you that came to yesterday's session will see that there is something missing here. When I do this dance on the server side, when I want a website to access an API, then here, not only I send the code, but I also send a key, a credential which says, yep, it's me. It's website X trying to access. But here, I don't do it because I cannot do it. A native application cannot be trusted to maintain a secret because this thing is in the hands of a user all the time. So the user has all the time of the world to attack this thing. Also, it's very difficult to find a way of distributing those keys. Like when I go on the App Store and I download the app, if the app would already contain the key, which happened a few years ago, now I don't want to say names because, of course, karma is not good, so I will withhold it. But a big social network a few years ago did their off dance in their native app in Android, and then the bits of their Android app contained the same key, one key, that was used for identifying their thing. And so, of course, in something like 15, 20 seconds, people extracted this key from the APK, and then they started to pretend to be twittering, oops, damn it. Damn it. Can we edit, please? Pretty please? Thank you. But anyway, it was the early days, so we all did interesting mistakes. But anyway, you can't do this. So the idea is that you can present yourself to the provider saying, yeah, I'm application X, but it's just like an indication. You should never use this as a security gateway. So once you receive a token, well, as we'll see in a second, which says this was obtained from application A, if application A is a native client, don't make any authorization decision on the basis of that. Only trust what the rest of the stuff that is in the token, but not that detail. But anyway, long story short, I send the code, and I get back, well, in classic OAuth, I get back 2 tokens, an access token. I don't know why they changed the colors on me. Hey, look at this. An access token, and yeah, I'm sorry, but my PowerPoint foo is not especially good today. And a refresh token. And we'll see a bit later on what happens, but the idea is that once I have my access token, that's exactly what I need for calling my API. And in fact, the next step is now this time programmatically from my app, I will make my call, and I will include in it my access token, specifically in an HTTP header, and the API will receive this token, validate it, decide that it likes it. Great. So that's the substance of what happens behind the scenes. And now you can happily forget it, mostly because we created libraries for you that hide all of those details. Now, those details aren't especially hard. It's 3 lines, literally, 1, 2, 3. But all the security considerations that go around it are the part that are hard. As in, at any of those legs, someone might try to inject itself, or someone might try to pretend any of the nodes in there. And there are a number of constructs, both in the protocols and in the tokens themselves, that prevent all of these attacks from occurring. So if you were to implement all of these yourself, you'd have to make a lot of work. As in, not only you'd need to make the dance, but you'd also need to do it in a secure fashion. And instead, we give you libraries that enshrine, I really like the word, some of these, actually all of those practices, so that you can be reasonably confident that you'll be following the secure practices. How many of you ever used the ADAL? Huh, very good. How many of you ever used the WAM? Let me expand it for you. Web Account Manager. Still nothing, huh? My friends in Windows Server will be very sad. Well, what can we do? Very good. So let's talk for a second about this ADAL thing. ADAL is really a family of libraries which we provide exactly for helping you to perform the tasks that I described in my diagram and more. Because like that diagram is typically what you see when people do a demo. But then when everyone goes home and the demo is done and you're ready to feel your evil, then you find yourself with your application, and after 1 hour, that first token that you get expires. And then you try to make a call, it doesn't work. And then you have to prompt the user again. And your user gets a prompt every hour. And again, very hard to keep your job after that. So there's also an aspect of session management which you get from those libraries, which actually make it so that that doesn't happen, that your user isn't bugged once an hour. But at the same time, you don't have to learn all the math behind that. So let's take a more detailed look in here. We have a family of libraries which are available across a number of different platforms. And I personally focus on the .NET one and on the JavaScript one. But I help maintaining consistency across the board. How many of you guys write Java code? 1, 2.5. OK. So you only write half and say, what is this thing? And you go back to C#. I do the same with Objective-C. I try, and I say, really? I didn't kill anyone. I go, why do I want to do this? And then I go on Xamarin, which I'll show in a second. They are all absolutely open source, as in like you go on GitHub/Azure AD, and you'll find all the code of all of the libraries. And if you want to see us working, you just look at the dev branch, and you'll see it every day going 2 days forward, 1 day backward. So that's how open source works, right? And you can, if you have problems there, please file issues there directly on GitHub. And the idea is that we try not to bring any Microsoft isms to other platforms. So like in Objective-C, we have the methods which end with the name of the method with name of the first parameter, which doesn't make any sense. But that's what Objective-C developers want, so we do it, by all means. But apart from these syntactic sugar considerations, the primitives that we have are across the board consistent. So if you learn the model in one platform, chances are that as long as you know the syntax of the other language, you'll be able to transport it verbatim to the other side. Then it works here there is one big misconception which plague the industry. OAuth 2 is not exactly an interoperable protocol. Like this spec is very vague on a number of very, very important aspects. So you might have A and B that both talk OAuth, and they might not be able to talk to each other. So in order to make the library something easy, something that helps you with your tasks, even if you know nothing about the protocol, we take advantage of all the things that we know about our own providers, Azure Active Directory and ADFS, if you want to be on-prem only, so that we can take care of many details, such as, for example, when you're getting tokens for 2 different APIs, but your user already authenticated, we have features which allow you to get new tokens without prompting the user again, which if you'd be just using pure OAuth, you would not be able to. So long story short, when you're using ADAL, you will not see a lot or at all of protocol artifacts. And you will not be able to use ADAL against any other provider apart from Azure Active Directory and ADFS. Again, if we would make this library to work with other OAuth providers, then this library will do 1/10 of what it does, as in like it would be much harder for you to use. So we went in that route. Why would you want to use another provider anyway? Like it beats me. I'm joking, of course. Don't tweet that I said that. or if you tweet, I'll deny that. Of course, always that, even in front of evidence. So specifically, ADL.NET is now at version v3. This will probably be the last version of ADAL, mostly because now in the new world, we have a new flavor of a service which consolidates Azure AD and MSA, Live AD. And then there will be a new, like a version 4 of ADL.NET will be renamed. It will be substantially still be ADAL, but just with a name which indicates it's not just Active Directory. And it supports in the same NuGet a number of different platforms. Like it works both in traditional .NET, so desktop, you write a console app, or you write a WPF app, or a WinForm app, or the code behind, or a classic .NET app, so also on the server side. Or if you want to target any of those other platforms, actually we have, like our NuGet is structured so that it has sub-assemblies which target specific platforms and allow you to do so. And in fact, like my main phone is an iPhone. Oops, I shouldn't have said it. Yeah, no, today actually, then it's more than fine. People are happy that I play with our software on the iPhone. And if I personally wanted to write something because I wanted to automate some of the aspects of my life, I actually use our Xamarin iOS because C# runs on my phone of choices. Why not? It's super easy, really nice. And one big difference between the desktop version of, like when you use ADAL on the desktop or when you use ADAL on the sandboxed platforms is that on the sandboxed platform, we save tokens in a persistent storage out of the box because we already know where to save it. Whereas when you're running on the desktop, we really don't know because you might be on the desktop, you might be on the server, you might want to use Redis, you might use Entity Framework. We don't know. So we have a pluggable cache model, and the default is just in memory. So important to take into account. Also, we have a number of, let's say, flows, like, for example, the username and password, which is a no-no for the reason that I said earlier. If you only grab username and password, and then you need to switch to 2FA, you have a problem. So there is a way of bypassing that browser thing, but we allow this only on old.NET, and chances are that it will take it away because our architects really, really don't like it. So if you are using direct username and password, please consider ways of moving to the browser version. And then we have a couple of other interesting things like the device profile. How many of you do IoT? Whatever that means. One, only one. Great. So marketing got you. Excellent. No, it's a very cool technology, but very hyped. And we have something for IoT, and I'll show it in a second. So this one is one of a few which I should actually animate. So basically, how does this work? ADAL gives you primitives which correspond to the thing that you would have in your head anyway when you're thinking about the scenario. When you're thinking about the scenario of an app which calls an API, you have the app, you have the API that you want to call, you have a place from where you are authenticating. So we have classes or parameters or methods which somehow help you to model this thing. And the base primitive is this authentication context. Authentication context is the moniker of your application, of your directory in your code. So you initialize this thing with that string, which we call the authority. And this thing basically says, OK, I want to work with contoso. The part which is on the right side of a slash is what we call the tenant, and it's really the directory that you want. The part that is on the left of a slash, login microsoftonline.com, indicates what we call the instance. Any of you guys from Europe? All right, look at this. I was from Europe 11 years ago. Now I'm American, as you can see here. Now I'm like, in Italy I was actually 98 kilos. Now I am 89, so somehow I did the opposite. But you don't care about that, right? We care about this. So the part on the left is what we call the instance. Azure has a number of different instances which are entirely isolated from each other. This week we announced the availability of what internally we call Black Forest, which was the European instance, in which you can run your stuff and know that you'll remain within the sovereign boundaries of your area. So if I'd be operating against Black Forest, sorry, whatever it's called publicly for the European side, here, instead of login@microsoftonline.com, I'd have a slightly different address. If I'd be operating the China instance, there is another instance just for China, I'd be using another address. So the authority is the combination of the instance and the tenant. For the vast majority of cases, unless you are using a sovereign network, login@microsoftonline.com will work as the global public network. All right. And then once I have my directory, how do I use it? This is like the main primitive that we have, this acquire token. This acquire token has substantially two important parameters. Like there's more, but the two main parameters are the resource that I want to access. In this case, I want old-fashioned Outlook. And every resource is tracked inside Active Directory, and it has an identifier assigned. It has more than one. And so here, I just provide that identifier. And the other, with very nicely humanly readable GUID, is actually the identifier assigned to my application. What in OAuth parlance is the client ID. Everything that happens in the AD world needs to move from one known app to another known app. And so in this case, those are the two identifiers of the two entities here. So the HTTP Outlook Office 365.com is the API. The GUID is my client. And the result, this authentication result, is what happened during the authentication. In fact, here, animation, technology. I get back this triplet of tokens. In reality, the main one that you care about directly is the one with the little lock, the access token, which is the token that you need for calling your API. But in this authentication result, you have lots of other things, such as, for example, who's the user that authenticated, whether the user is about to have its password expire, and so on and so forth. And you can see the classic can in there. That can represent the cache that ADDL uses, and you end up automatically caching all these tokens. That's why I'm saying you care only about the access token. It's the only one that you use directly. You do authentication result dot access token. Everything else we take care of. Like, for example, this thing with a little swirl is the refresh token. And I will see a bit later why it's useful, but you never see it. We have it and we use it transparently. You don't actually need to see it in your code. Well, before we get there, let's be bold. Let's write a little up. OK, so here, just for demonstrating that this actually works, let's create a new project. And, well, it's not very fashionable to use Windows Form, but I'm going to use it anyway. And the thing that I'm doing now, you can do exactly in Windows Form, WPF, UWP, console, Xamarin, iOS. So it's all the same. And in a second, I'll open an existing project once I talk about Xamarin that shows you how it's actually structured. So here I have my little app, and let me add the ADDL NuGet. And here it's easy. You write ADDL. Then you'll see that there's many. Don't accept any imitation. Only get the original. The original is the one with more than 1 million downloads. All the other ones somehow are in its orbit, or people like the acronym for some reason. But the main one is like the one that says Microsoft Identity Model, blah, blah, blah. So let me just add this guy. I accept every time it asks me. And voila. Now I have my assembly. Let's do a beautiful, beautiful minimalist UI. Maybe before tomorrow. And voila, you have a button. OK. So here, what I want to do is just get a token for calling one API. Now, I could start writing code, but given that I mentioned that I need to register everything first, let's do it. Let's go to Azure AD, and let's let Azure AD know that I'm creating a new application. So let's go to portal, azure.com. Today I'm going to be, let's be the administrator. I type really fast. No. Okay, so here there is the very familiar portal. Only recently we got Azure AD added in preview in the new portal, which is what allows me to show you this very sleek and streamlined experience. Otherwise, we'd have to be with the old-fashioned portal. So you find the application that you develop under these app registrations. I don't judge. And if you're clicking there, you'll find the list of all the applications that you created. And if you're the administrator, you'll see all the applications that everyone created, which can be a bit overwhelming. Look at this. So let me add a brand new application. And adding a brand new application is very easy. Let's call this Ignite Native. And let me zoom in so that you can see what's happening in here. Here you can see where you have to make this big decision at the beginning. You have to decide whether you're writing a web application or an API, something that lives on the server, gets its own credentials, can be a recipient of a token, as in a resource in itself, or a native client, something that requests tokens for others, runs on devices, all the stuff that we said earlier. So we want to be a native client. And here you have to provide what we call the redirect URI. What is this redirect URI? Remember that in my little picture, I've shown that when you need to authenticate, you get that UI that comes out from the server. Now, this UI will present whatever the server deems necessary to authenticate the user and gather the consent that it needs. But then it also needs to find a way to signal to the application that, OK, I'm done. I've done everything I needed. So now close and resume your native flow. And that is done by redirecting on that URI. The redirect URL has exactly that function. And interestingly, this doesn't have to be a network addressable URL. Let's say that, for example, when you are on Android and you are doing this, typically the schema of a URL that you are using will be associated to your app, so that it is guaranteed that the Android system dispatches the forward of a token specifically to your app. So here, of course, I'll just use the traditional one because I'm doing something very, very standard. Right. OK, so let me create the app. And I successfully created it. And now, very helpfully, it disappears in the sea of other apps. And so now, what am I going to do? Well, given that I have this thing, and I cunningly wrote a name that I remember, sometimes I just do like I just do a random, and then I say, and now how do I find the app? Instead here, as you can see, I just wrote Ignite, and I find my application. So here I see a number of things that I can control of my app. In particular, I see this client ID, the application ID. Remember that in the standard pattern, I need this client ID in order to obtain the token. And then in these required permissions, there's the list of APIs that I can call, like the actual APIs that I want my application to be able to access. And here, by default, I can get this permission. Let's see what is this permission, which is sign in and read user profile, which is pretty good. But I'm eager to do more. Actually, here, there's another little detail. I don't know if you can see. Actually, let me help you to see it. Here are this list of permissions. And the permissions have these green or red things. Now, I believe that the spirit behind those colors were to help the administrator, as it's always the case with Azure AD, the directory people run the show, for saying, oh, beware. Like the red permissions are permissions that the end user can consent to. So those are the ones that you need to be careful about because your users might be getting, how to say, might be getting information that you don't want to share as an administrator. Now, if you put yourself in the shoes of a developer, which are your own shoes, then it's kind of the opposite. Like when you are picking the ones that are green, those are permissions that can only be granted by administrators. So if you choose those permissions, then what happens is that when your app runs, unless the user is an administrator, the user will not be able to authenticate because they will be presented with the consent. And when they try to give consent, unless they are an administrator, they cannot consent to any of the green ones. So normally, it's the opposite. Let's say like you have to be careful. As a developer, you have to be careful about the ones that are green, and instead the ones that are red are guaranteed to work with end users. It's a little subtle, but hopefully once you see stuff running, you'll see better what I mean. So here, let me just add another resource. So here, let me select an API. And in particular, those are the APIs that I have available in my tenant. If I would have created my own APIs, I would have my APIs as well here. And I want the Microsoft Graph because it's very fashionable. So you select it. And then here, I want to do something like, I want to read the user mail. Yes. OK, so from now on, as you can see, I have these two guys. Perfect. So now I can go back and start writing code. So let me come back to the blade here, and let me copy this application ID because I'll need it. Of course, I allow access. OK, so now we are back in Visual Studio. Let me make this thing a bit bigger so you can partake in the joy of writing this. Well, writing on the stage is never fun, but I do what I need for getting my salary. Sorry. Now, this is one of the most important tricks when using Visual Studio, which changed my life. You write something which is in an assembly that you added but is not yet in the using. You hit Control dot, and magically you get this dialog. And voila. Maybe you already knew, but I had to share it anyway because it's a huge productivity boost for me. So here I have my authentication context, which I described earlier. That's the object which represents my directory. And the directory that I picked here is this developer tenant. And, well, yeah, there's no way around it. I have to type it. So let's type it. Again, Microsoft.com, developer tenant on Microsoft.com. Yeah, one thing that you might have noticed, or probably you didn't, when I signed in the portal, I used an administrator of this directory. But this directory is a test directory which is not associated to any Azure subscription. So in the new portal, you can access the portal for functionality like Azure AD, which are not necessarily tied to Azure, even if you have no subscription whatsoever. So if you are working more in the Office development orbit, and you don't have Azure for some reason, or your developers don't have access to the Azure portal, which is also the case, they can always use the new portal, which is a very nice feature. OK, now I have my authentication context. The next. Say again? MicrosoftOnline.com. Thank you so much. Thank you, thank you, thank you, thank you. In fact, I was going to say that the one who gives me the best question gets a book, but you just saved me, so this book is yours. Well, you can, if you have a shorter leg on your table, you can use it for. OK. So here, now I want to extract the token for this guy. So I have this authentication result. This is the point in which I remember that this thing has to be async. Because here I have to await. I see dot acquire token. So now comes the interesting part. Acquire token has 11 overloads. That's a non-trivial number. The idea at the very beginning of the library, 3-4 years ago, was like, oh yeah, we just do a few overloads, and you know what are the information you have, so you'll just pick the right one. And then scenarios kept growing and growing and growing, and we ended up with 11. Now, in the new version of the library, we split some of these methods, and we started adding details of a parameter in the name of a method. So this problem is solved. But here, for the time being, you actually need to know the overload that you want. The good news is that we have 61 samples. So normally, you never do what I'm doing right now. You just go on GitHub, and you clone samples, and you start from that. So here, we want to first specify the resource. Actually, let me be a bit more string resource equal. And the resource that we want, we said, is the Microsoft graph. So graph Microsoft. After 15 years, one would think that I would know how to write it. But of course, no. And then we want the client ID. Client. I blame it on the table, which is really low. I have to be crouched. And here I add my GUID, which I copied from the portal. And then we want a URI. New URI. And I think, let's just copy it, just in case. OK, great. So now here the order of parameters is, this is the resource for which I want my token. And I am this client ID. And my redirect URI is, helpfully, redirect URI. And then here you have this parameter. The new parameter which we introduced in version 3, which is a way of doing late binding for platforms. So ADIL can operate in all of the platforms that I described, desktop, NetCore, iOS, Android, and similar. When you do UI in iOS or Android, you need to integrate with their UI mechanisms, like, for example, the activities and similar. Or if you are a multi-window application and you want to pop a dialog specifically to be, say, tied to one of those windows, you have to specify what you want, like what window you want. So in other words, there are platform-specific parameters that you need to pass in order for the ADIL to know where it's running. The default is the desktop. So here, I'm not passing any pointer to Windows and similar, but I do need to pass the expected visual behavior that I want to have. So here, I have this prompt behavioral construct. And of course, let's see if I manage to be fast enough. Yes. You can see these 4 options that I get in there. This is the way in which I want my prompt to behave. Like once I make this call and I want the token, I need to pop out something. And that something can show always the UI. If, for example, I know that I'm calling this because I want a new user, not a user that I already encountered before. So I just want to make sure that the user is prompted. Or I can have this auto, which would be the default, which is if you already have something in the cache, just give it back to me. Don't bother showing anything. The other is never, which is the opposite of always, which says, well, if you have something in the cache, or if you can use a refresh token to get a new token without showing any UI, do it, otherwise fail right away. And the refresh session is for another time. So here, I'll do auto, just for the zest of it. OK. So now I compile. Compiling is always easy. Let me just place a little breakpoint here. And let's hit F5. Beautiful, beautiful UI. click my little button, and here you see this dialog, which is substantially a web browser dialog. If I'd be in any other platform, I'd be seeing the experience which is typical of that platform. Like on iOS, I'd see the classic iOS with a little Chrome around, like cancel, go back, and similar. Android the same. And here instead, I see this. Let's select Mario. And here there's a famous consent. What happened is that when I created the application, I will see this a bit later. It will be the most boring part of the presentation in which I'll explain in details how this works. But the idea is when I create the app, I only create the abstract class, like the template of the app. I'm not really instantiating the app in my own directory tenant. So what happens is that the first time that someone tries to use it, they get prompted saying, hey, this application is from this developer tenant on Microsoft.com. And it's trying to do those two things. It's trying to sign in as you. It's trying to see your details as a user. And it's trying to read your email. Are you OK with that? And if I say accept, actually helpfully, oh, good, very good. Never mind. It's if I spend too long blubbering. Yep. Also, I did a mistake. I hit F5 now. But never mind. Windows A, sign in. So I get this little dialog, and we say accept. Basically, I just get the token, but you won't know because I hit F5 and so. But here, there's a nice thing. If I hit this first button again, and now I hit F10, as you can see, nothing comes out. Why I didn't get a dialog? Because I have everything cached already. So given that I have everything cached, this is giving me back the cached token instead of popping out the dialog again. And the good news is that this will remain the case while the application is open. If I would provide a persistent storage to this app, or if I'd be using these on one of the sandboxed platforms that have the persistent store out of the box, then this thing would be the case for the next 90 days. I wouldn't have to get any dialog again. And here there is our, it's really an exercise of being super fast. I could, but I'm lazy. So I'm going to do this fantastic locals. There you go. There you go. And now I dare you to make it disappear. Here there's the content of for his authentication results. And the main one that you care about is the access token, because it's the one that you grab and you attach to the API call, which we'll see in a second. OK. So very straightforward. You don't need to know any auth for doing any of this. So the way in which normally this works, like this one is just for a demo, but normally you always want to first get sorry, wrong slide. Like you never take this authentication result.access token and save it in a variable and then just use this variable. Every time you need a token, you always want to call an acquire token of some flavor. Like, for example, acquire token silent, which is a method which never shows the UI. So that if your token, so first if you have a cache token, you get it back. So it's not less efficient than having it in your local variable. It's just exactly the same. But if the token that you have is expired, then if we have a refresh token behind the scenes, we'll get a new token for you transparently so that you don't need to write the code which manages the case in which this thing is expired. And also, it goes beyond that. Like the refresh tokens that you get from Azure AD are multi-resource. Let's say that you can use the same refresh token for getting access tokens for new resources, which you didn't access yet, but that you consented to. And if you would not do this, you'd need to know that logic, and you need to know which refresh token you use at what time. Complicated. And we do it instead ourselves. OK, let's talk for a moment about Xamarin. How many of you guys use Xamarin? Okay, for everybody else, Xamarin is some kind of magic that allow you to write C# code and then execute it on other platforms such as iOS, Mac, Android, and similar. And this thing is done because we ported various say platform-specific classes so that you can have intermediate code that runs on those platforms. And the way in which we support this is interesting. Like if you, I assume that all of you know what is a NuGet. Who knows what is a NuGet? Everyone. So for everybody else, a NuGet is just the way in which you distribute software libraries in the .NET world. Now, there is this nice and not very well-known utility called the Package Explorer, which allows you to actually take a look inside those packages. Those packages are just like zip files. And so here, I can just search for my own NuGet. And once I find it, I can open it. And let me zoom in. So this is the content of the ADAL NuGet. The ADAL NuGet is really a collection of assemblies, rather than just one, in which I have target platforms. So the first one is the set of NuGets that I have, the set of assemblies that I have for Android. The other one for the desktop. The next two are for .NET Core. And then there is a portable class library, which contains most of the logic without any of the platform-specific stuff. So only network, but no storage, no UI. And then finally, there is the iOS one. And now what happens is that when you develop with this stuff, normally, if you want to write a project which spans multiple platforms, you'll structure your solution in this topology. You'll have one portable class library project which contains most of the logic. Like you'll have like all the logic that mostly executes at this level without anything which is platform-specific. And then you'll have platform-specific projects which somehow deal with the various individual differences. If you are using Xamarin Forms, those projects will be very, very thin, very small, because like, even the UI is in there. But in the generic case, you can expect to have some specifics. Now, when you have, like all of those are projects. When you go and you do add the NuGet package to these projects, what happens is that the Visual Studio knows the flavor of your system. So substantially, say that I am adding the NuGet reference to the iOS project. What happens is that what I really get in here is a reference to the PCL assembly and a reference to the iOS-specific platform. So the iOS-specific platform is the assembly that contains the UI classes for showing that stuff in iOS, the storage classes, the things that use the keychain or the things that are iOS-specific, and the PCL instead is like the generic base. When I do the same with the PCL project, I only get the PCL project, and then, of course, I'll just have a reference between those two, and then everything works pretty nicely. In fact, just for showing you the structure of these, let me just quickly go on GitHub. I said quickly. Yep, here we are. If you open this in Visual Studio, it's just for giving you a taste of what this looks like. Okay. So as you can see here, I have a collection of projects in my solution. It's loading, initializing, taking its time. Thank you. And just for giving you an example, you have like one PCL project, which contains the base of this. Like this is our sample that you can find on GitHub. And it's a very easy app that just searches for users in a directory. And all the search functionality is in the portable class library. And then there are like all the platform-specific ones that just refer to that. And they're just like little details. Like the only difference here is when I am in Android, remember that platform parameter that I used in .NET. In Android, I have to pass in that platform parameter the reference to the current main activity. It's the only code that I need to add in there. Everything else comes from the other part. From iOS, I have to do something to that effect. So it's very, very easy to very easy to work. Yep. And I actually have a demo that runs from the Mac. But given that we don't have a lot of time, and given that you'd see exactly the same stuff that you have seen, but running on a Mac, I hope you can believe me that it works. If you don't, you can download the sample yourself. But I just want to make sure that I touch on some of the other things that were still open. So one thing that I wanted to mention is you want to use ADAL when you're targeting all versions of Windows, like from Windows 7 onward, when you want to do things on the desktop and not just with universal apps and similar, or when you want to target also iOS, Android, NetCore, and similar. When you are targeting exclusively Windows 10, then Windows 10 itself has a number of APIs that come with the operating system. And they offer you the ability of taking advantage of user accounts in the system. So when you sign in to your device, since Windows 10, since the very first version of Windows 10, you can actually sign in to your device using your Azure Active Directory, like your Azure Active Directory account. And then if you use these APIs, then you can use the same user for getting a token for any other API from your application, as long as your application is a universal app. Now, in the Anniversary Edition, you can use these APIs also for desktop apps. However, this works exclusively only if you work on Windows 10. It's a very nice mechanism. It's extensible, so if you want to add your own providers. And the pattern is slightly different. Well, slightly. It's different from ADAL. And the sequence is, there is a call which goes against the system and finds what we call the plugin that you want to use. Every identity provider has a plugin directly in Windows 10. And in our case, you'll say like a commercial, something to that effect. Like there is a specific string that you say, I want Azure Active Directory. And then once you have these, you construct your request. Like this is closer to the protocol than ADAL. Like there is a class which represents the request, and you just add parameters to it. And then you take the provider that you obtained from one, and you call request token async, passing the request, and you get this web token request result, which has the token that you need for making the call. Now, one potential side effect of this is that in the process, the user will be asked if they want to add the user to the system. And sometimes that means that your device will be joined to the Azure AD cloud domain, let's say, so that all the various device-specific flows will be available. And just to give you a super quick taste of this, let me open an app in here so I can show you the experience of being prompted to do that. I can't say that I want a faster machine because I don't think there is a faster machine than this Surface. But if you want to write in the feedback that Microsoft should buy me a faster machine, don't let me hold you back. So here I have a UWP application which does something really, really simple. It's, to me, it's basically a time machine. Because it's an app that helps you to take a picture of yourself and post it as the thumbnail in your user. And every time that I use this app, I see the picture that I took last time, and I always have less white hair than when I do it again. And it's very, very sad. So here, let me sign in as Mario. So as you can see, the dialog is slightly different from what you have seen earlier because it's a dialog which is driven by my account manager. Once I sign in, see that it gives me the opportunity. Let me zoom to show you the exact text. It says, hey, do you want to take this account and add it to the system so that I make it available to everyone else running on the machine? And my answer is always skip for now. Otherwise, my demo is over. And then here, look at this. handsome, no. Okay, let's not do this. But anyway, as you can see, the experience is different, and it allows you to go deeper in the operating system integration. So it's good, but it has, how to say, it's a trade-off. So just for helping you with a trade-off, you can use this API if you are targeting Windows 10 exclusively. And if like one other possibility that this thing offers is that it can use any provider as long as that provider has a plugin in the system. Today, we have only 2 providers, Azure AD and MSA, so it isn't super different from what you get from ADIL, but in the future, we might have more providers. And then ADIL.NET works, again, only for Azure for ADFS and Azure AD, but it gives you this wide range of platforms you can target. And also in terms of object model is consistent with completely non-Windows platforms. So before we wrap, I just wanted to make sure that yeah, you are lucky. I went too far, and so I'm not going to give you the very boring but potentially useful thing. So I just wanted to make sure that I cover quickly what is the Microsoft Graph API. The idea is that Microsoft offers many different hierarchies of entities which are very useful, like SharePoint, Exchange APIs, Azure APIs, CRM APIs, Power BI APIs. And whenever you want to get a token for those, normally you have to make a call like the one that you have seen, in which I do acquire token, and I pass the resource identifier. Now, given that we have these multi-resource refresh tokens, then you prompt the user only once, and then you just, I'd say, keep getting new tokens silently. But in fact, you end up having multiple tokens in your cache for multiple different services. And also, when you are actually making the call to the API, you end up with results which are largely disjointed, as in like you get a certain hierarchy, a certain graph under Exchange, and then you get another graph under Azure. And so if you wanted to cross-correlate those things, it's very difficult to do. So enter the Microsoft Graph API. The Microsoft Graph API is a facade on top of many of those entities, which unify basically the way in which you talk to those. So you get only one token, which works with all of them, and you get the results which all belong to the same hierarchy. So that if you wanted to cross-correlate documents and calendars and files, you can do it very easily instead of having to do 3 different queries and then figuring out the foreign key yourself. So very handy. It's a classical data API, so very straightforward. And we have libraries for dealing with that, or you can write it directly on the wire, which is what I prefer. And the structure for making calls is very easy. It's like, here I want to talk to the Microsoft Graph. This is the version I want to use. This is the tenant I want to use. This is the entity that I wanted to query. And then you know what data allows me to specify, even in more fine-grained details, the kind of results I want. And here, like the way in which you navigate it further is this, but OK, perfect. And again, if you didn't go to the graph presentation so far, I invite you to catch some other one, because you'll be amazed at all the things that you can do with a graph. OK, so we didn't spend a lot of time on the Azure AD App model, but we did see that on the portal, so I consider that checked. We have seen how easy it is to get your tokens using our libraries. And it's useful to know what happens behind the scenes, but in fact, you can happily live without. But you saw it once in a lifetime. Good. You can put them a check mark. You can tweet that now you know how this stuff works. And we took a very quick look at the Microsoft Graph. There are many, we are almost done, so the only other things that you can actually, there are still interesting sessions you might want to catch. Like this afternoon, there is a session on B2C which is a similar service, but not for your employees, is for your customers. So very useful, I recommend it. And this one instead is a bit more for administrators. You know what? All the other ones are for administrators, so who cares? No, yeah, of course, they are very interesting, but if you are a developer, just be warned, they are for administrators. And if you want to dig further, and please do, we have a number of URLs which are very out of character, easy to remember, because they are short and more or less meaningless. Sorry, meaningful. Freud, he's hitting me again. And you can use these, like the first one is like the jumpstart for all of our documentation. Then all of our samples, 61 of them, live under that moniker. We have all of our source open. And if you write questions on Stack Overflow, we actually have runners that warn us when they find the keywords of our technology. So please don't be shy, hit us in there, and we'll help you. And that said, I am exhausted because this is the third session that I had in this Ignite, but I'm selfless. So I'll be for something like the next hour, hour and a half at the AD booth. So if you are not sick yet of my very, very thick accent, please come by and we'll talk shop. Thank you.